Hello everyone. Today we will be discussing a problem on Newton's divided difference formula. In the previous lecture we discussed about divided differences and Newton's divided differences formula. Now we can discuss an example. Complete the divided difference table for the data in the table and construct the interpolating polynomial that uses all these data. Here we are given for 5 points, that is x0 equal to 1, x1 equal to 1.3, x2 equal to 1.6, x3 equal to 1.9 and x4 equal to 2.2, and also we are given the functional values of f at these points. So first we have to construct the divided difference table. So here we know this is the first this is the function value at the point x0, that is f of 1. So we know this is the zeroth divided difference at the point x0, that is f of x0 is this is f of x1, this is f of x2, f of x3, f of x4. Okay, now using that zeroth divided differences we can find the first divided differences. Okay, so the first divided difference involving x0 and x1, this is x0 and this is x1, so it is f of x0 x1 is equal to f of x1 minus f of x0 divided by x1 minus x0, where f of x1 is the zeroth divided difference at the point x1 and f of x0 is the zeroth divided difference at the point x0, which are actually the same values, values of f at that points x0 and x1 itself. Okay, so from this we get this is f of x1 and this is f of x0. So using that values we get this is f of x1 minus f of x0 divided by x1 minus x0. We have x0 is equal to 1 and x1 is equal to 1.3. So simplifying this we'll get negative 0.4837057. So this is the first divided difference involving these two, that is x0 and x1. In a similar way we can find the remaining first divided difference values, that is by using these two and these two. Okay, so these are if you are trying to find that first divided difference values, you will get these values. Okay, actually here we obtained the first divided difference by using these first two values x0 and x1. It is minus 0.483757, which is this. Okay, now using this 1.3 and 1.6 we get this value, that is this minus this divided by 1.6 minus 1.3, that is f of x2 minus f of x1 divided by 1 by 1.6 minus 1.3. Okay, that is x2 minus x1. So we'll get this, and using these two values you will get this, that is this minus this divided by 1.9 minus 1.6. That is the first divided differences using x2 and x3, and using x3 and x4, that is 1.9 and 2.2, we'll get the first divided differences of this. Okay, so you can just verify these three. Okay, it is actually obtained from these. We just verify these three. Now after obtaining these first divided differences we will get the second divided differences. Okay, so for the second divided difference involving x0, x1 and x2, x0, x1 and x2, that is this is x0, this is x1 and this. So the second divided difference involving these three is obtained by using the first divided difference of this. Okay, that is this minus this divided by 1.6 minus 1.0 is f of x1 x2, that is this is f of x1 x2, and this is f of x0 x1. So f of x1 x2 minus f of x0 x1, that is minus 0.548940 minus this. Okay, divided by this 1.6 minus 1.0, 1.6 minus 1.0, that is x2 minus x0. So simplifying that we'll get this f of, this is actually f of x0 x1 x2. Okay, this is f of x0 x1 x2, and by using these two, that means 1 by 1.3 and 1.9 by using these. That is the for second divided difference involving x1, x2 and x3. x1, x2 and x3 is obtained by using these. This minus this minus this divided by 1.9 minus 1.3, and you will get this. You can also verify this. And the second divide difference using 1.6, 1.9 and 2.2, that is x2, x3, x4 is obtained as this. You can just verify this. Now the third divided difference involving x0, x1, x2 and x3, that is involving x0, x1, x2 and x3, that is involving these four. Third divided difference involving these four values is obtained by using these two. Okay, this minus this divided by 1.9 minus 1.0, that will be this. It's actually here yeah, f of x1, x2, x3 minus f of x0, x1, x2 divided by x3 minus x0. That is f of x1, x2, x3 is this 0 point minus 0.01 0.049443, that is this, minus f of x0, x1, x2 is this. So using that values you will get this 0.06588784. That's this value. Now in a similar way you can find the next third divided difference. That means by using these 1.3, 1.6, 1.9, 1.2, that is x1, x2, x3 and x4. Using this x1, x2, x3 and x4, you will get the third divided difference like this. That is this minus this divided by 2.2 minus 1.3. So we obtained the third divided difference. This was our zeroth divided difference. This is first divided difference. This is second divided difference. This is third divided difference and fourth divided difference. We have only five values: x0, x1, x2, x3, and x4. So the last divided difference will be fourth one. So fourth divided difference will be obtained by using this third divided differences. This minus this divided by 2.2 minus 1.0, that is x5 minus x0. Okay, that is this f of x0, x1, x2, x3, x4 is equal to f of x1, x2, x3, x4 minus f of x0, x1, x2, x3. That is f of x1, x2, x3, x4 means by using this minus this. Okay, that is this minus this divided by x0, x5 minus x4 minus x0. Okay, that is 2.2 minus 1.0. So we will obtain this as the fourth divided difference. So we obtained the zeroth divided difference, that is 5 divided zeroth divided differences, and from that we obtained 4 first divided differences. Then from that we obtained 3 second divided differences. After that we obtained 2 third divided differences, and last one we obtained 1 fourth divided difference. So this is f of this is f of x naught. This one is f of x naught. This is f of x naught x1 first divided difference. This point is this is f of x naught. This is f of x naught x1. This is f of x naught x1 x2. This point is f of x naught x1 x2 x3, and this is f of x naught x1 x2 x3 and x4 using all the values. And this is actually f of x1. So this is f of x1 x2. This is f of x1 x2 x3. This is f of x1 x2 x3 x4 and etc. Now, by using these values, by using these diagonal entries, that is f of x0, f of x1, x2, x0, x1, f of x0, x1, x2, f of x0, x1, x2, x3, and f of x0, x1, x2, x3, x4, we can obtain the interpolating polynomial. So we know the interpolating polynomial as Pnx is equal to f of x0 plus f of x0 into x1, f of x0 x1 into x minus x0, f of x0 x1 x2 into x minus x0 into x minus x1 plus etc. f of x0 x1 etc. xn x minus x0 into x minus x1 into etc. x minus xn. But here we have n equal to 4, that is we have 5 points. So p4 of x is equal to f of x naught, f of x naught plus f of x naught comma x1 into x minus x naught plus f of x naught comma x1 comma x2 into x minus x naught into x minus x1 plus f of x naught x1 x2 and x3 into x minus x naught, x minus x1, x minus x2 plus f of x naught, x1, x2, x3 and x4 into x minus x naught, x minus x1, x minus x2 into x minus x3. Right. Here we have xn, so here we have x minus 1. So here we have xn, f of x1, x1, x2, x3 and x4. So here up to x minus x3. Okay, now we can just replace these divided differences, f of x naught and f of x naught comma x1, f of x naught, x1, x2, etc. So replacing that values, we get this. So we have f of x naught is equal to this one. This one is f of x naught, this one is f of x naught comma x1. This is f of x naught x1 x2. This is f of x1 x2 x naught x1 x2 x3, and this is f of x naught x1 x2 x3 and x4. Okay, so we are using only these diagonal entries in this table. So replacing that, we get, so this is f of x naught, and f of x naught x1 is this, f of x naught x1 x2 is this, f of x naught x1 x2 x3 is this, and f of x naught x1 x2 x3 x4 is this point. And this is x minus 1, this is, we know this is x naught equal to this is x naught, x minus x naught, x minus x1, this is x minus x naught, x minus x1, x minus x2, this is x minus x naught, x minus x1, x minus x2 into x minus x3. So this is the required interpolating polynomial. So this polynomial P4x agrees with the function f at the given points x0, x1, x2, x3 and x4. That means at these points 1, 1.3 etc. 2.1, f and P4 has the same values. Now we have a note. Newton's divided difference formula can be expressed in a simplified form when the nodes or the points are arranged consecutively with the equal spacing. That is, if the points x0, x1, etc., xn are arranged at an equal distance, then we can express the formula, divided difference formula, in a simplified form. In this case, we can use the notation h equal to xi plus 1 minus xi. That means if this is the point x0, if this is the point x naught, then x naught plus h is equal to x1. So this length is h. So x1 minus x naught is equal to h. x1 minus x naught equal to h. For I from 0 to n minus 1 means that when I equal to 0, we have x1 minus x naught is equal to h, and when I equal to 2, we have x2 minus x1, sorry, when I equal to 1, we have x2 minus x1 is equal to again h. That means x2 is placed in a distance h from x1. Okay, this is x2, and x3 is again like that. x3 is placed at a distance h from x2, etc. and xn. So we have in this case, and let also suppose that x is equal to x naught plus sh, x equal to x naught plus sh. Okay, so then the difference x minus xi is x minus xi is equal to s minus I into h, because we have x minus xi is equal to x equal to x naught plus sh. So x naught plus s into h minus xi is nothing but xi is x1 is x naught plus h, x2 is x naught plus 2h. From this we get x2 equal to x naught plus 2h, x3 equal to x naught plus 3h, etc. So xi is equal to x naught plus I into h. So this is nothing but x naught, that is xi is equal to x naught plus I into h. So x naught get cancelled, then the remaining part is x minus I into h. So x minus xi is equal to s minus I into h. If you are you assuming x equal to x naught plus s into h. So our the equation, the interpolating polynomial becomes, we know the interpolating polynomial is f of x naught plus summation k from 1 to n this into this. That means f of x naught plus f of x naught x1 plus into x minus x naught, f of x naught x1 x2 into x minus x naught into x minus x1 plus etc. This. Here we have replacing these values. That means Pnx is equal to this equation. This is our interpolating polynomial. Now this becomes Pn of x equal to, we have x is equal to x naught plus sh. So Pn of x naught plus sh is equal to f of x naught plus f of x naught into f of x naught comma x1 into x minus x naught. We have x minus x naught is equal to s minus 0 into h, or s into h, right? We have from this we get x minus x naught is equal to s into h. So we can replace this x minus x naught by s into h, and f of x naught x1 x2, that is here. Now x minus x naught can be replaced by s into h, and x minus x1 can be replaced by s minus 1 into h, because we have x minus xi is equal to s minus I into h. So x minus x1 is equal to s minus 1 into h. So this can be replaced by s minus 1 into h. So we have uh, s into s minus 1 into h square, s into s minus 1 into h square into f of x naught x1 x2. In a similar way, we get the other terms also. So the last term will be f of x1 x naught x1 x2 etc xn, that is here, into x minus x naught into x minus x1 etc. So that will be s into s minus 1 into etc s minus n plus 1 n minus 1, that is s minus n plus 1 into h power n. So this is nothing but, in sigma notation we can write this as f of x naught plus summation k from 1 to n. Here we have up to n. So k from 1 to n, s into s minus 1 into etc s minus k plus 1 into h power k f of x naught x2 etc xk. Now we have, by using binomial coefficient notation, we have SCK is equal to s into s minus 1 into etc s minus k minus 1 divided by k factorial, that is s minus k plus 1. S minus k minus 1 is nothing but s minus k plus 1 divided by k factorial. This is SCK. So we can replace this by SCK into k factorial. So this polynomial becomes Pnx is equal to Pn of x naught plus hx, which is equal sh, which is equal to f of x naught plus summation k from 1 to n SCK into k factorial into h power k f of x naught x1 x2 etc xk. So we can represent the divide difference formula in this way also.